Hello, everyone. Thank you so much for joining us today. We are Pittsburgh Java User Group. I'm Sirisha, and I've got Renat here as well on the call, who is, yes, he just waved his hand before I could say anything. That's good. He is admitting people into the call. So you can learn more about our events and just about us on the meetup.com. But you can also follow us on Twitter. All of our recordings from 2021 and 2022 are up on YouTube channel, and we will do the same for 2023. This is our first session. So we like to start our first session of the years in February. That's a long story, but that's how we like to do things over here. And then we'd like to thank our official sponsor, JFrog. And with that, I want to hand it off to Olga and Sam. You can take it away. Please introduce yourselves, and yeah. Looking forward to the session.
Well, is it? And, well, hello everyone. My name is Olga. I'm a co-founder and CTO at Modern. My background, I was a product manager at Pivotal for Spinnaker, and prior to that, engineering and data protection at EMC. Sam?
Hi, I'm Sam, a VP of engineering. My background is in developer tools and improving developer happiness through better tools and automation of TDM. I have worked at several companies like Tableau, Microsoft Gradle, and most recently Modern, mostly all on that theme. It's a pleasure to be presenting to you today.
So today we're going to talk about automated software refactoring. I don't know how to, sorry. Automated software refactoring with two very different technology, engine, 100% accurate rule-based system, and OpenAI, which is a very different system. It can be used to automate code very quickly, but it suffers from something that is known in industry as hallucinations. It's not an accurate system at all. However, we could marry the two and leverages in particular specific use cases that kind of accelerates our automation. So agenda, we will talk about the problem first. Why do we need mass scale software refactoring? And looking at the problem, we'll look at what characteristics we need in our solution. We'll talk about OpenRewrite, the background, the core refactoring technology, why it is possible to create 100% accurate style preserving source code to source code transformation. And then we talk about how we can complement OpenRewrite with targeted usages of OpenAI to make things faster. And then I'll pass it to Sam, and we'll do demo. So the problem is here. We've created a lot of software, and yet we still don't have enough. How much, can we visualize how much software we have? One of our customers, a large size enterprise, 200 million lines of Java code. If we put it in books and write it as text and stack these books one after another, it will stretch for 75 miles. But it's not only large organizations that are affected, the small organizations too. One other customer we work with, 70 engineers. A decade ago, they had 40 repositories of code. Now they have almost 1,000, 25 times the amount of code per engineers in just 1 decade. And the problem is even worse because it's not only all of the software that's running in our applications. We all know that software is now assembled, 80 to 90% of it comes from open source. It's not under our control. It evolves, dependency change, CV being fixed, API being changed, new innovations being contributed to open source. And what our engineers do is keep trying to update, remediate, the custom software that we've built. And we are now sort of throwing bodies at the problem, trying product engineers, everyone fix CVEs, etc. When Log4Shell comes in, we try to put everything on pause and try to fix our software, and it just like really do not scale anymore. But because the problem became so repeatable, everyone is fixing Log4Shell, everyone is migrating Spring Boot 1 to 2 to 3, Java 8 to 17. It points us towards automation. So OpenRewrite was born at Netflix out of necessity to make one such migration. There was an internal library that the founder of this technology, Jonathan Schneider, worked there in engineering tools at the time, and they wanted to migrate an internal login library to Log4j, and they deprecated this library, and there were still like 500 million lines of code, million references in the code bases throughout it. So it felt like impossible. And there was also a culture of freedom and responsibility, meaning that central team cannot put any gates into what product engineers are doing. So it was not possible to say at this date, if you still use this library, you will be broken. So they felt hopeless. And people were saying to him, like, if you do it for me, I'm happy to take the change, but I'm not going to be doing it myself. I'm not going to come to work and just do replacing login statements with one another. And he heard it and decided to try to automate it, and kind of very narrow migration at first, replacing login statements and stuff, but also needed to be format preserving because of this freedom and responsibility. Netflix code base didn't resemble one repository to another. So it needed to be solved, the stylistic consistency of the fix going into a code base. So as you see some examples here of transformations that are possible now, it's import manipulations, making sure that code bases that use tabs will insert with tabs, spaces, number of spaces will be preserved, the brace styles, etc. So what's underneath? Why is it possible? The technology is built on no manipulation of lossless semantic tree of code. And it's like a superset of everything that compiler knows about the code at the time when it resolved all of the dependency, all of the type attribution, etc. It's filled with this like a super SBOM, not just with all of the transitive dependencies, but all of the code references. It's like populating the abstract syntax tree with other metadata, and also going back to the source code as text and scooping up formatting and putting it on a tree as well. And then we have, that's the representation of code we operate on. And then we also have a catalog of recipes. Recipes are building blocks that transform the code. They manipulate the tree, and then sort of we write out code as text so the developers can review it and accept the changes. So recipes like a lot of things like change type, change method name, reorder arguments are encapsulated as a part of the framework. And if a developer wants to write more complex transformation, they can escape into like the programming language and write an imperative recipe in Java. So what kind of use cases we have here? So first of all, migration engineering, moving framework forward, Java 8 to 17, Spring Boot 1 to 2 to 3, JUnit 4 to 5, various best practices for Spring Boot, logging frameworks, security vulnerability remediation. We've been working with one security researcher, Jonathan Leitschuh, who had a scholarship from Dan Kaminsky Fellowship last year that allowed him to remediate vulnerabilities in open source. And he used our platform to issue thousands of pull requests, fixing zip clip vulnerabilities, fixing things like and secure path traversal, etc., and improve code quality. All of the majority of this like SaaS type of reporting things could be rewritten as recipes. So we go with our users or with our customers and we look at the tools that they have inside, and they often say, you know, top 10 things will take you 5 years of time. And when rewritten with automation, that they're complete almost just review time that's left. So they have a growing ecosystem of modernization. We work with Quarkus teams and Micronaut teams, and they contributed to renovation recipes for upgrades of their consumers. We are also working with Sprint team. They have a couple of people working with OpenRewrite, and obviously Sprint is very large. The surface is quite large, and there are still holes in the support, and we're kind of working towards covering the whole ecosystem with recipes. So at the time when people want to upgrade, the remediations are available to them. Obviously, as part of migrating Java, we had to do a lot of properties, XML, Gradle. We recently added COBOL, also Terraform, Kubernetes layered on top of YAML, various CI systems, test containers contributed refactoring recipes. And right now we're building on it. We're working towards adding TypeScript, Python, and C#. And it's interesting, we will be able to add this programming languages much faster than we expected, because these languages actually on the AST model, they share the same grammar island. It was in academia, they call a C family of languages, even though in text, these languages look very different. On the IST model, they are very similar. Think if, else, method calls, etc. So represented the same. So today we will be doing, about to pass this to Sam to do a demo, and we'll doing it on our public.myden.io tenant, which is free service for open source. We have like right now millions of lines of open source popular projects in the tenant, and we will run the same recipes. So the tenant is pre-populated with LSTs that been already pre-compiled and produced, and they are in that environment, and recipes being programs now that they run on a pre-compiled LSTs. They will produce results very quickly, and we'll be able to demo you a broad range of different refactorings, rather than the same things you could do with the build plugin. It just takes longer. I'll introduce CodeAI and then I pass it to you, Sam. So all of us on the team are currently using Copilot, which is also backed by OpenAI. It is very interesting, the experience. We believe it makes us up to 30% more productive as engineers, because when you author code, Copilot makes a suggestion. It very often it's the right suggestion, and it saves a lot of time typing. Like we say when we write code, like our hands lag behind our thoughts. We think much faster, and then we try to catch up with our hands. And so Copilot can come in and like create a whole piece of code for us. And we like accept or rejected code. So we talk about it being suggestive. It's up to us to review and accept or reject the change. But going back to the problem statement, the massive amount of code that we have, and like thousands of repositories, and even for 70 engineers, we cannot review all the inaccurate suggestions. We really need, like in case of framework migrations, we don't need a creative tool. We need an accurate tool, because when we migrate an API or we migrate versions of something, we look at the release notes for the review, the new version of something, and we know exactly what are we going to be doing. Move this rename this, change this, and we're going to do it 1,000 and 1,000 and thousands of times. And that's kind of why the rule-based engine is important here. But and also kind of we need to fix code everywhere while we create code in IDE in one particular space. And so I'm going to pass it to Sam to talk about how we can marry these two systems given their different characteristics.
Great.
I'll
Thank
stop
you,
sharing.
Olga. So I'll start off by just demonstrating a recipe execution to kind of make some of what we've been talking about so far a little bit more concrete for everyone. And then I will proceed to demonstrate an algorithmic handcrafted refactoring recipe that we authored and an AI-based refactoring recipe that has very similar functionality so that we can kind of compare and contrast the pros and cons of these things and see how they can enhance each other, how the characteristics of these different kinds of systems or approaches to problem solving can complement one another. So let's see. So over here, I have our public SaaS hooked up to all those open source repositories that Olga mentioned, and I'm just going to run this common static analysis issues fixes recipe to just kind of show you what that looks like and what sorts of results you get back from running something like this. So, we kick it off, and this is made out of a collection of handcrafted Java programs that ran on those LSTs and went and fixed several of the sorts of things that a linter or static analysis tool like, find bugs or SonarQube might complain at you about, things like putting the modifiers in their canonical and expected order, or, getting rid of unnecessary types and diamond operators, all of these little things. And, if we wanted to, we could go over here and, issue commits or pull requests or what have you with this system. And so let's kind of compare. Let me show you how one of these refactoring recipes is implemented. So these are the tests that we have, our unit tests for our default comes last refactoring recipe, which is one of these kind of static analysis fixes type recipes. And this one specifically, for a switch statement, takes the default case and puts it at the end, which is, canonically where one typically expects these to go. And, we cover various cases in our unit tests, and the actual implementation of the recipe that does this looks like this. We have a visitor pattern that goes and visits switch statements and has a bunch of logic that was lovingly handcrafted by one of us or an open source contributor, because again, OpenRewrite's open source, and I'll show you where that is on GitHub for anyone who wants to take a look later. And, there's a decent amount of logic in here in order to effect that fairly simple change. And we have just under 200 lines of, yes?
Someone is asking if the color of the background can be changed so that they can see better. I don't know. Yeah.
How about I make the text bigger? How's that?
Yeah, I think that's better. Increasing the font is good.
Okay.
Cool. Yeah, thank you for that. Right. So, a programmer given a couple, some amount of time could read through this, understand it, find bugs, augment it, and it took, some number of hours to produce and test this code originally. And, let's kind of compare this with a recipe with very similar functionality that is implemented with the help of an OpenAI model. It's dramatically simpler, right? We just have a little bit of code to go visit switch statements and to identify if there's a default statement. And if there is, we just ask the model, hey, could you put this switch statement with the default case last in natural language? That's a heck of a lot easier to write and understand at a glance than the deterministic handcrafted version of the same. And just like that, the original one, we have some tests for it. And the thing about AI, though, or a thing about AI or model-based manipulations, is that their results can be kind of unpredictable. The exact same query presented with the exact same input can sometimes have different results. So let's run this and see if, there we go. So, for the first 3 repetitions of this test, everything worked as expected. But on the 4th repetition of the test, it did something a bit unexpected. It it introduced a whole new case statement for us, as well as moving the 0th case around, which leads us to a slightly different way of engineering than one might have done with the deterministic or the more algorithmic based approach, where we might come in and decide that based on this unexpected response, we need to tune our request of the AI system a little bit and say, and here's GitHub Copilot helpfully trying to anticipate what I'm going to ask this other AI-based system to do. But I'll say, do not introduce any new case statements. I'll say, do not introduce any cases. Do not reorder any existing cases. So we might try to get more specific and run it again to see if we can more reliably get the results we want. And this kind of dovetails into some of the strengths and using the strengths of each of these system approaches to problem solving to offset one another, as it's very easy to make a request of a model, but the results you get are unpredictable. Whereas with the deterministic algorithm or approach to problem solving, you get very predictable results, but it's let's see how we might have to tune the query differently this time. You get more predictable results, but you you have to yourself exhaustively account for every situation.
Yeah.
Okay.
I think one other thing here to mention, we kind of pre-parsed the code and then identified the case statement before we even gave it to AI. We only gave her we didn't give her random code. If we just gave it a random code, it would be a magnitude worse. So that's why like the rule-based system located the potential for transformation, translated it back into text, and fed the AI with different prompts into it. And so I think the use case here is trading the accuracy of recipes for speed of developing them, and then, more thorough review. So when you do something like a one-off things, like migrations that you don't expect to repeat, and it's a narrow use case that, reviewing 10 things and accepting or rerunning the recipe versus investing the time into building the accurate recipe.
Yeah, and on that same theme, it is typically much easier to validate that something has the attributes you want or is the correct solution to a problem than it is to enact the transformation. So, the code that we could write here to validate that the default case is indeed last is much simpler than the code which would transform it. So you could pair deterministic verification with fuzzier AI-based changes to kind of further ratchet up the confidence that even if you might not get exactly what you want out of the model, you would at least detect that it wasn't giving you what you wanted and reject making changes based on that. So we see that there is a lot of potential here to use these techniques in a complementary way. And having had this experience doing that, I now find debates about deterministic methods versus AI or model-based methods to be kind of missing the point, as when they work together, they can offset each other's weaknesses and accentuate each other's strengths. But we found that these AI methods can be applicable to more than just affecting the actual transformations themselves. They can also be useful for making sense of all of the things that that we can query or learn about software through this system. So, as a company that is aspiring to be able to parse and produce LSTs reliably for almost every programming language in major use today, here's a recipe that we use ourselves to improve the quality of our parsers. And this recipe just finds parsing failures, files that we cannot parse correctly. And we have it produce a data table, which is just tabular data, CSV or Excel spreadsheet of all of the files that we found that something was not able to parse correctly. And I'll show you what that data looks like now. So here is the kind of raw form of that data, where we record which repository and which file, which branch, and a snippet of text about what the stack trace was like. And for this handful of repositories that I've run it on, this is a pretty manageable amount of data. And as a human, I can kind of look at this and quickly kind of see, well, these Groovy parsing exceptions are probably related. But as the number of repositories increases and the variety number of programming languages being parsed increases and the variety of the errors increase, this kind of manual analysis becomes more and more onerous and error prone, and it becomes easier to miss what the most impactful error is. So we've been investigating how to further enhance the process of analyzing this with AI, and I will kind of show you what we have on that so far. So this is a Jupyter notebook that operates on the data produced by that recipe, the raw data that I just showed you, and it loads up the data, reads it in from Excel into a table, and then it asks. And kind of the task we're looking for this to accomplish is to take all of these potentially hundreds or thousands of failures, group like ones together, and then kind of name or categorize those groups so that we can see not that we have 10,000 failures, but that we have 5 kinds of failures, and the one that fails most often fails 3,000 times, so that we don't waste time investigating a failure that affects 1% of files when there's something that affects 30% that we could look at first. And so in order to try to group similar failures together, well, that's an operation on a stack trace. We want to find similar stack traces, but making a determination, or common algorithms for grouping things together, like k-means, operate on numbers, not strings of text. So we first need to kind of map text into some numerical form whereby similar numbers or similar text will have similar numbers, so that we can then use the statistical methods that we are familiar with to identify clusters and group things together. And so to do that, we use the OpenAI embedding model to say, hey, turn this text I've given you into a bunch of vectors in some vector space that means something in the internal magic of this AI model. And so we pass that in, and we get back a vector of values out of there. And then, now that we have numeric data, we can use a deterministic, non-AI based algorithm, k-means clustering, which many of you are probably familiar with from your own engineering work, or at least your statistics class back in college, which tries to cluster related data points together. And again, purely deterministic, no AI involved, but impossible to apply to text, at least in its raw form. And so this provides a kind of another example of what I've been talking about, of the fuzzy AI-based system making or enhancing the usability of a deterministic system, that they work together and are more powerful together than either was alone. And finally, we apply colors to each of the groups that have been identified, and we spit out this chart where you can kind of see on this 2D space the different groups. The colors were the AI model turned each of the text snippets into a vector, and then the k-means clustering identified what the different kind of clusters of related errors were, and we can see by the number of circles around each cluster how kind of roughly how many of that kind of error is present. And so very easily and repeatably, we have kind of performed an automated analysis of a great deal of information. And we can even take it one step further because, right now at this stage, what's the blue? What's the blue group? What's the green group? I don't know. Right now, they're kind of just the blue and green group, and a human can manually go in and look at the stack traces associated with the blue group and start to come to a determination about what the commonalities there are, and to start to figure out what the theme of the error cluster is. But now we're in this kind of like fuzzy asking a question of your data place again, where we might as well ask another AI model, hey, could you please tell us what these stack traces have in common? And even prompt the model, kind of print the theme of this group here. And kind of what we get back from that is what this model kind of thinks the commonalities of the stack traces are. This cluster 0, there's a type mismatch, class cast exception. And, these are kind of basic summaries, but that says something about, the stack traces we're giving it as well, that maybe there isn't more for it to go on. But either way, it's kind of a start, Now a human can go and look at this and evaluate, and I think that is critical that you should always evaluate what AI tells you, since it doesn't know what it means exactly, right? You have to, you can't take it at face value, but this kind of gives you a start for making sense of your data very, very quickly compared to what it would take to manually perform all of this analysis. So we see that the kind of the potential here is huge, and it's already very promising. Well, so that's go ahead.
Also, we could look for code duplication or very, similar code in different places that could probably be removed. Kind of give us insights into what to refactor to improve our applications.
Yeah, absolutely. Yeah. So let's see. Any questions about anything we have said so far?
I have one question.
Please.
And we'll monitor the chat as well to see if any more questions. But you can always unmute yourself and ask a question too.
Yeah, feel free.
So the OpenAI pieces, the AI pieces that you were showing us, is that like something that's experimental right now, or is that already part of the software?
Good question. So and I'll share my screen again and show you. So here is the main OpenRewrite repository on GitHub. It's where the core refactoring technology is. Everything in here is completely deterministic and handcrafted. We have another project where we've started to, the one that I demoed to you earlier, where we've started to experiment with using OpenAI in conjunction with our deterministic refactoring technology. And so here's that default comes last recipe. If you want to go and try this out yourself, you totally can. The one thing you will have to do is supply your own OpenAI token, because right now we're issuing requests to an external service that we do not control. And so you should be able to see in the project how to go about that. But if you want to experiment with that or otherwise have any questions, you're welcome to pop into our open source community Slack and ask me directly, and I'm happy to help you out with that.
So OpenAI is a third-party API, and it's backing Copilot, ChatGPT, and all other popular things right now. But you can.
Longer term, I think our plan for how we'll integrate this into our code once we've kind of moved further beyond the experimental stage is that we would package free and open source models into our libraries directly, where they could be used and reshared without having to worry about hitting the rate limiting of an external service that might be down or not accepting your HTTP requests or what have you.
It's also like it's consumption-based pricing. So if you're doing a lot of it, it's probably going to get expensive.
Mm-hmm. Got it. So, yeah, the one thing that I probably missed this. How do you get started? Like, how do you start using this right now? Like, is this like a library that you would add in your form file, or was this something that you would use as a web UI? Like, how do you get started?
To get started with OpenRewrite today, I've just put some links into the meeting chat. The easiest way to do it is to use the build plugins we have for Maven and Gradle, where you can apply those to your build and start running any of the library of refactoring recipes that we provide, or any that you might author yourself. And yeah, that's the easiest way to immediately get started. That and going on public.modern.io, which is free for anyone to access, and try out running the recipes that we provide in-house across the many open source repositories that we've ingested from GitHub.
Got it. Cool. Thank you so much. Yeah, I wanted to know like how to get started with using the.
Yeah, great question. Thank you for asking it.
Yeah, cool. And thank you for the links. That's helpful. And
absolutely.
You also mentioned that this was free for anyone to use, right?
Yes, it's all Apache 2 licensed, so free and open source, including for profit purposes.
Got it. Cool.
I have a quick question. Actually, I forgot the question. Sorry. Yeah, the one thing that I wanted to actually check is in our team, we are doing a lot of upgrades. And I think Olga started with the upgrade. She showed us some Java 8 to 14 and things like that. Is there any sample project in your GitHub that shows us how to go through an upgrade? That would be a very useful thing for us to explore.
Yeah, so for that, we have, so if you go to our documentation website, just like our quick start guide, which shows how to get started with the Maven and Gradle plugins, provides an example of cloning we copied Spring's Spring Pet Clinic migration project, and provide a demo here of how you can run various recipes, including our Spring upgrade recipe. Yeah, so we have some upgrade recipes for some common Java libraries like JUnit, Mockito, Spring, Quarkus, Micronaut, and it is possible for anyone who is motivated to create an upgrade recipe for some other library or platform, whether open source or internal to your organization, to do so. So yeah, I would check out the getting started guide on docs.openrewrite.org, and I'll just go ahead and put the link directly to that one in the chat.
Oh, thank you so much. That would be really helpful.
Yeah, and if you have any problems or questions about it, join our community Slack. I'm in there all the time, keeping an eye out to help people getting started with this stuff.
Yeah, I think, like I mentioned, like we're still working on kind of creating the breadth of recipes. The ecosystem is really wide, and we welcome contributions and feedback and help us prioritize what to build.
Yeah, absolutely. Every day, people in our open source community are adding new recipes for Spring Batch and for PowerMock and other things that we have not had the bandwidth to cover directly, but that are of interest to them. Yeah.
So, this is Shyam.
Hi.
I'm seeing that this OpenRewrite is Apache license, right?
Correct.
So basically, that means like the Maven library will be there in Nexus.
Yes, yeah, we publish all of our libraries and the Maven plugin to Maven Central, and our snapshot builds of nightly stuff are published to the Nexus snapshot repositories.
Okay, then so can I run this analysis local within IntelliJ once I download the plugin, or do I need to run it
We don't have an IDE plugin for IntelliJ yet. We plan to have more tool integrations with IntelliJ and GitHub Actions and command lines and such in the future. But right now, the kind of two paths we have for running search or refactoring recipes are the Maven and Gradle build plugins and the SaaS, the public tenant that I've been demoing from.
So, okay, so I cannot run the analysis within the IDE. That's what I'm hearing, right?
Correct. You'd run it on the command line.
Okay.
And if you have any problems with that, send me a message and I'll help you out.
Okay.
Oh, is this the same technology which is used in ChatGPT? You said it's I mean it's based on the OpenAI.
Yeah. The AI based recipe we have, which is right now just in the Rewrite Generative AI project, uses the same OpenAI models and API that back ChatGPT. I saw that we had in chat, we say recipes, what exactly is under the hood? A recipe is our term for a unit of work that does a search or refactoring operation on one or more pieces of code. And typically those are implemented with one or more visitors that might visit Java or XML or both in order to, say, make a code change to your Java and also go and update your dependencies in your Maven POM or your build.gradle. Maybe you go edit a properties file or some YAML settings as well. So that's what we mean by a recipe.
Yeah, and there are a lot of recipes pre-built, like for very common things like change method name, change type, reorder arguments. And on the public SaaS, you can actually see the catalog of all the recipes that are available. You can search them. There is also in OpenRewrite documentation, we have the same catalog. But here you could try running them and see what transformations that they will create.
Awesome. Thank you, Olga. Sam.
Great. Any other questions or comments that anyone has? If not, that's all the content we have for you.
I think Istvan
yes. Hey, I just have a question. So you said you are allowed to run this command line. So what kind of connectivity it has to have just to that upstream repo? So the reason I'm asking, because I'm coming from a company who's extremely restrictive what you can connect to, and to be able to run anything, it's probably will have to open up firewalls. So what kind of connectivity requirements it has just even to POC out something?
Sure. So for a typical recipe that you're running with OpenRewrite, you need no external connectivity whatsoever, except for whatever artifact repositories you were already using to build your code. We publish like the OpenAI recipe that I showed you. This one makes a call to an external service to OpenAI's REST endpoints. All of our other recipes are entirely self-contained, except insofar as like a dependency manipulation recipe might want to call out to an artifact repository to see what artifacts are available, but it would only be aware of the artifact repositories that you had already given like your Maven or your Gradle build access to. It wouldn't go and just query some random repository. So this OpenRewrite is suitable for being run in isolated environments or air-gapped environments, and doesn't necessarily need any resources that you're not already making available to your build tool.
All right, it's cool. So as long as we have some kind of artifactory or Maven central cache, we should be able to utilize it in the building without worrying about shutting it down halfway through on the way out. Cool.
Correct. Yeah. It's a very common setup for corporations or government entities to mirror Maven Central in their internal Artifactory or Nexus repos, and that works very well.
And I think the other interesting point that this OpenAI recipe illustrates is that it's a program. You can do anything you want with it. Like one of our customers wrote a recipe that interrogates lunch darkly, looks for unused feature flags, rips out the code, rips out the feature flag, and like cleans up code periodically, right? So
yeah, each of our recipes are programs, and if you want it to, you can make it do anything in addition to making code transformations. You could have it, if it's suitable for your purposes, query some external environment. The recipes we author don't do that, but you might find it useful too, in which case, go for it. That's great.
So is there any limitation on running the recipe locally, like number of times?
No, you run it as much as you want.
Okay.
yeah, and just to talk about if you want like our commercial offering, we work with a lot of large enterprises. We are SOC 2 Type 2 compliant, etc. That a lot of security questionnaires has been filled out, and it's a single tenant SaaS that we provision and integrate with your on-prem environments.
Yeah. If you want something, so the build plugins we have are really great for applying a search or transformation operation to one repository. But if you're even a medium-sized organization, I mean, heck, we're a small organization and we probably have 100 repositories at least. If you're a medium or a large organization that has hundreds or thousands of repositories, well, going into each of them and applying a build plugin and running a recipe may still be quite a lot of manual work. And if you want to, like I did earlier on this recipe, on the common static analysis run a transformation across dozens or hundreds or thousands of repositories, and potentially just go ahead and start a mass commit campaign across all of them. Well, this service is designed to facilitate the running of the search or refactoring operations at scale.
You guys mentioned something at the beginning about Sonar or analytic, when you have like a SaaS tool providing results that it can come back and out. Is that a recipe you already have available?
Yeah, so that's part of what I'm showing on the screen right now is the results of our common static analysis issues recipe run on a selection of Netflix and Spring projects. And I can click on any one of these and go look at the changes it's suggesting, in terms of simplifying this lambda expression or anything else. And if we go back to look at the recipe definition, we can kind of see that our common static analysis issues recipe is a collection of smaller recipes, which is kind of a key point, something Olga alluded to earlier, that these recipes can be building blocks that you can assemble together into ever larger and more complex recipes. So our common static analysis fixes is a collection of many different recipes that each fix, one issue that say SonarQube might complain at you about. And we even have links here in the tags that we could see this explicit initialization recipe is related, intended to automatically remediate this violation that Sonar or a similar static analysis system might complain at you about. I find as a programmer, there's many reports and compiler warnings and other sources of things saying, hey, go fix the code. And I'm like, I already have a list of things a mile long that need fixing. What I need to make progress isn't another list of things to fix. It's actually making the change to fix the thing. And now you've actually helped rather than just nagged me about something.
Yeah, I think it's interesting. We have senior programmers on the team. Everyone is really good, and yet we run this recipe on our own code on a weekly basis and make commits. Just you forget and you get distracted and things like this sneak in.
Yeah, I remember one principal engineer saying that sometimes he felt like trying to enforce any particular coding standard or best practice across their code base, he felt like a parent chasing after his kids saying pick your socks up off the floor, put them in the drawer, and that he hated having to do that. It's not the dynamic you want as a leader or mentor on the team. It's tedious, it can breed resentment. Much better to have an automated system do that for you. If your rule is something that you can encode in an automated way, stop having holy wars about curly brace placement, right? Just leave it up to the auto formatter.
So I have one more question. So
Yeah,
what are
please.
the features, what are the additional features that we get while running the analysis in a public.moderno.io domain compared to command line?
The main thing is being able to run across many repositories. If you're doing it on the command line, you're running a single build on a single repository. Whereas, if you're running across, many repositories, like I've talked about, like I've shown here, then you can, look at, start aggregating information across many repositories, as well as making changes across many repositories. So I'd say probably the big advantage is scale, but the refactoring recipes themselves are exactly the same.
Okay.
Also, the code is pre-compiled, and as it goes into the tenant, and on a command line, every time you run a recipe, it needs to compile the code. So the time of running a recipe is proportional to compilation time of your repository. So it's much faster. And then from the perspective of roadmap, there is like we're taking this expert system and making it more in a recommendation service change campaign, like data tables. You can collect data on vulnerabilities across of your all the repositories in minutes. So
Okay. So in the command line, does it generate HTML output? Like
Typically, the command line has kind of two modes it can run in. One is the run mode, where it will just change the files on disk directly, and you can then use git diff or what have you to review the results and decide if you want to commit them. And then there's a dry run mode, which will generate a patch file, which you could review in a text editor and decide if you want to ask Git to apply those, or your version control system to apply those changes or not.
And mind you, the recipe will output a data table, but you're running it on a single repository now. Now you have a single row in Excel spreadsheet. You have to aggregate. It's everything by yourself. Like everything that we do here, you can achieve with open source. It's just going to be taking much longer and much more scripting and other effort that you would have to put into it.
okay, thank you so much. The another question is in the recipe list, do you have for the Java versions, do you have any recipes based on the Java versions like a JDK 11, 15, 17 like
Yeah,
that?
we have some upgrade recipes for Java 8 to 11 and from Java 11 to 17 that you can try out. There weren't too many breaking changes between Java 11 and 17, but we've started to add some recipes to take advantage of new patterns that Java 17 enables, like smart casting instance of statements. And just on the subject of dependency vulnerabilities, since we brought that up slightly earlier, I thought I'd just show you this recipe run of this dependency vulnerability report that I just ran across that same set of open source repositories and generated this data table based on the OWASP database of security vulnerabilities of every vulnerability that we could find in in each of the repos with the affected artifact and what version is in use and what version, if any, is known to that database to have a fix available. And so this data table is kind of complementary with like making, like we can have that complementary with making changes to the files themselves. Look at this guy. Okay, yeah. So this is just a search result that mentions that somewhere in this file it found these vulnerabilities. We haven't wired this up for build to make dependency changes to build.gradle files yet, although it's possible. So I was just looking for one that was built with Maven. No, looks like all of these are all the ones we're reporting things right now are built with Gradle. But anyway, we can have it. We could take it a step further even to if a fixed version is available and it's only a minor or a patch version away from the version you're currently on, could both give you a report and again try to fix it for you. Like, hey, here's a pull request that updates the version number as well. And we see this as a way to really automate out a lot of the tedium and repetitive tasks that are involved in the day-to-day maintenance of a big code base.
Cool. And I think this was mentioned in the presentation, but there are also plans for Python and TypeScript support as well in the
Yes,
future.
we're working on right now we're actively working on Python and Kotlin support, and within the next few months we'll be working on TypeScript, and then later on in the year C# is kind of up next.
Awesome.
Yeah, thank you.
Yeah.
Well, yeah, thanks for the great questions and for your time and attention, everyone.
Yeah, and thanks for a great presentation. It's definitely
Yeah.
very relevant in the current world.
Very relevant. Lots of interest. You can see that by the number of questions we got, which is typically not how these things run. So definitely there's a lot of interest, and I'm sure you'll be getting more hits on the website today. So thank you.
Excellent. I look forward to it.
Yeah.
Yeah.
Thank you for the excellent presentation.
Thank you.
Yeah. Thank you for your excellent questions.
So we will have this recording up on YouTube in a few days. Also, I noticed that the meetup invite already has all of these useful links under the useful links section, the links from this chat. So I think that will be a good starting point for anyone who wants to really use this. Yeah, I think that'll be, I actually was going to go and put it as a comment, and then I realized it was already documented. So all of this is already there.
And I'll
if you
include
want to
them
get
in
started.
the YouTube description, video description as well. So it's there as well.
That'll be awesome. That'll be awesome. Yeah. Thanks a lot, Olga and Sam.
Yeah, thank you so much.
Have
Thank
a
you.
good weekend, everyone. See you all for the next session.
Thanks.
Yep.
Bye.
Bye-bye.